Welcome back, Mindsetters. Wow, I love seeing all the answers on the page. I mean, you guys are going along with every question that Phil's doing, and it's wonderful to see your focus. And it just means that now when you go through the past paper by yourself, you have all the answers and all the explanations. So make sure you're also taking notes. Over to you, Phil.
Thanks so much. Okay, well, just before the break, we ended off with 2.10. Some people asking questions about the oxidation numbers. Just a reminder of what's actually going on here. The way that I assigned the oxidation states was I took the unknown element and I added it to the charge or the unknown, to the known oxidation state of sulfate ion. I added it to the charge of the ion. I made them both equal to 0 if I added them together because copper sulfate is neutral. What that does for us is that leaves us with an oxidation state of positive 2. So what I'm going to do is I'm just going to highlight the one which is correct, and I see some of you on the page are saying 2.10 is option C. Now let's just get rid of some of the ones that it cannot be. A metal. Now I can tell you 99 times out of 100 a metal cannot be a negative charge. So that's option A and option B off the table. Now copper itself has got two common oxidation states of positive 1 and positive 2. And positive 4 is a little bit out of the question for something like copper. So what I'm going to be doing is I'm going to be moving on to the long questions now. I hope that you guys join me. I think we're going to have time to squeeze this one last in. I can't believe how time is flying. Okay, so there we go. Let's get into these long questions and let's see what goes on. Okay, so now in question 3 of this paper, what I'm going to find is that I've been given a whole bunch of formulae and a whole bunch of structures. Now, when you're given a big body of intimidating questions like this, what I've got to do is I've got to slow down and say, okay, well, what out of this is actually important? Don't go sit there and try and name all of them. You weren't asked that. So what I'd advise that you do, go look at the questions below, and let's try and go back to those molecules and see if we can figure out what's going on. Now they say, write down the letter. So this is not a lengthy question. This is not one that requires a lot of explanation. So it says, write down the letter that represents the following. Okay, 3.1.1. It tells me that I'm looking for a ketone. Now, if I remember correctly from our first multiple choice questions, let's see what a ketone actually is. A ketone is a C double bonded O, but here's the difference. It is in the middle of a chain. It cannot be at the end, because if it is at the end, that makes it into an aldehyde. What I find is that this, that double bonded O on our option D here is definitely a highlight for a ketone. Notice how it's not at the end. So now, see, I'm just going to highlight the same thing in our aldehyde. So if I do the same thing to an aldehyde, option A is an aldehyde. D is a ketone, and that is the difference between those two. If I find the carbonyl right at the end, it's likely that you've got an aldehyde. Okay, so a ketone, let's just fill in our answers as we go. A ketone is option D. A compound, which is an isomer, just remember that an isomer has got the same molecular formula as prop-1-ene. So we're looking for something which has got prop-1-ene. Prop-1-ene has got a general formula of C3H6. The way that I did that was I knew that this was an alkene, and that means that I've got a general formula of CnH2n. Now that helped me figure out what the general formula for propene is. So I'm looking for something with the same molecular formula as C3H6. Now that's quite easy. I can cross out option A. There's way too many carbons. Option B, possibility, but there's too few hydrogens. I found that there's only 4 of them. Option C, I think I might have a winner here. 1, 2, 3 carbons. I've got 2, 4, 6 hydrogens. I've got C3H6. That's cyclopropane. Now you might say, well, how is it possible that a propane is an isomer with a propene? Well, it's because of the ring. You'll find that cyclic compounds are isomers of alkenes. So what do I find there? Option C is the correct one. Let's just make some space there. option C is the correct one, which gives us an isomer of propene. So let's just put these answers in brackets so that you know what's happening when you're doing these examples. Okay, now 3.2. I've got to do a little bit of challenging here. It says, write down the IUPAC name of the following. Now we've got to do one for compound A and one for compound B. So let's spend a little bit of time on compound A and B. Okay, so compound A, let's first of all identify the longest carbon chain. That's the first step in any sort of naming process. So I can see one which goes there. You could even count around the corner. It's going to give you the same length. 1, 2, 3, 4, 5 gives me pent. Now, because those carbons are single bonded, I find that it is pentan. Now, something special I see on the end of this thing. I see that there is a carbonyl, and it's with an H. That means that I've got an aldehyde. So what I'm going to do is I'm going to say pentan. Now, in the same color, pentanal. Now, you can say pentanaldehyde or pentanal. It's the same thing. They will accept both. Now, that doesn't tell me what happened to the last piece over there. So let's just highlight what else is going on there. I have got a 1-carbon side chain. The question is, do I start numbering from the left or do I start numbering from the right? Now, here is the way you decide. I changed the end of pentane. Because of the al, that's where I start numbering. Pentanal is an aldehyde. So I start numbering from the right-hand side. So that's 1, 2, 3, 4, 5. On the 4th carbon, I find a 1-carbon chain, and that is methyl. So what I'm going to do is I'm going to move this all into a neat place. Let's move it all down there so we can make space for the methyl. Okay, so pentanal. Let's make space for 4 dash, because remember that you've got to make space between the numbers and the words with a dash. So it would be 4 methyl. You don't separate words unless you separate the carbons. So 4 methyl pentanal. So I hope that you can see from the colors, the green is my backbone. That's the one that I started with. I found out which homologous series it was. That tells me that it was an aldehyde. And then on the 4th carbon, I found that there was 4-methyl. Okay, now let's carry on with this. We're looking for an IUPAC name for carbon compound B. Carbon compound B is a little bit easier. So what I'm actually going to do is I'm going to move all of this out of the way. Let's move that name all the way over there, and let's keep it by that compound. Okay, now what I'm going to do is let's name option B. Let's do it the same way. Look for your longest carbon chain. All of a sudden, I see that there is 1, 2, 3. 3 gets me prop. Next question I ask myself is, how are they bonded? I see that there is a triple bond. That triple bond tells me that this is an alkyne. So it is propyne. Now, is it possible that it could be in another position? Absolutely not. It could be in that one. It would be exactly the same compound. So all I've got to do is say propyne. It's not wrong if you said prop-1-ine, because it's in the first position, but not necessary. If it's in the first position and you just say propyne, that's absolutely fine. Okay, so we've got those two names. Now we're getting there. So it says write down the name or the formula of each of the two products formed with a complete combustion of compound E. Wow, okay. There's a huge amount of crazy words going on here. Let's just try and figure out what's going on. So it says the name or formula. They don't mind which one. Of each of the two products. So we're looking for two products formed when I have a complete combustion. That's our clue. Of compound E. Now, I don't even have to look at compound E before I know what's going on. Compound E is butane. But this is a hydrocarbon. Anytime I burn a hydrocarbon, there's two particular products which always come out if it is complete. And those are carbon dioxide and H2O. Now, just a reminder, carbon dioxide, if you were watching the show before mine, Bruce's, carbon dioxide is a greenhouse gas. Now, they might ask you about that. Okay. Right, we're almost at the end of question 3. I think we're going to have a little bit of time. Okay, so it says compound F is the organic product between a carboxylic acid and ethanol. Write down the following. Okay, so compound F, let's just take a look at what compound F is. Compound F is ethyl butanoate. Okay, now it wants the structural formula of the functional group. Sorry, let's just get there. Sorry, the name of the homologous series first. I've skipped a question there. Let's just go back. The homologous series to which compound F belongs. Ethyl butanoate. It splits into 2 pieces. That's a very good sign that what you've got in front of you is actually an ester. Okay. An ester has got 2 parts to the words, and that's a very good sign that you've got an ester. The structural formula. Okay? So that means that I've got to draw this out. The structural formula of the functional group. They just want the functional group of carboxylic acids. So they want me to draw the thing which makes carboxylic acids carboxylic acids. So basically what we've got to do is called a carboxyl group. A carboxyl group has got a C double bonded O with an OH on it. It's almost like an aldehyde and an alcohol combined into one, and in fact that is exactly what it is. That is called a carboxyl group. Okay, now here's the challenge. The IUPAC name. Now we've got to do a little bit of detective work of the carboxylic acid from which compound F is prepared. Now I'm going to give you a few clues, and we're going to work through this slowly. Let's first write out the name of that compound. So ethyl butanoate. Now when you're naming an ester, what you've got to do is you've got to realize that the 2 parts of the name actually come from the 2 parts which went together to make the ester itself. Ethyl came from the alcohol. So the first part of an ester's name came from the alcohol, and that's where the ethanol came in. They told me that there was ethanol. Butanoate came from the acid. So what they're expecting me to do is to draw out butanoic acid. So let's draw out butanoic acid. So now this one's really easy. All I've got to do is follow my formula. First, bute. Bute tells me that there are 4 carbons, and because it says and, they are single bonded. Now to make it into butanoic acid, the oic acid means that I've got to put on my carboxyl group onto that last one. And then all we've got to do is fill up with hydrogens, and we are good to go and to get our marks. Now, I think we've got time for just the very, very last question before I say goodbye to you guys tonight. So let's just finish off question 3. Now, I'm trying to find out what the structural formula of compound F. So they want me to draw out full-on ethyl butanoate. Now, this is quite easy. If I take my acid and I put this next to my alcohol and we draw this all together. So let's redraw my acid. And let's draw this all together. And what we're going to find is 1, 2, 3, 4 from butanoic acid. So there we go. We've got our hydrogens again. And we're going to have to do this in a little bit of a rush to make sure that we finish on time. I'm not sure how much time we've got left. But let's try and figure out what goes on the other side. What changes when you make an ester is you make an oxygen bridge to the ethyl part. So I hope that you can see that my ethyl part comes onto that oxygen. So we've taken butanoic acid, we've made it into a butanoate. So let's just highlight this. This is the ethyl part, and this is the butanoate part. And that is the last of question 3. And that
Thank
seems to be a good point to end it off tonight.
Yes,
What
it
do you
is.
think?
That is fantastic. Thank you. Thank you, Mindsetters. You were absolutely amazing today. I know that you matric, some of you have written, and you're like, wow, that paper was easier because of mindset. And some of you are still going to write. So good luck to every single one of you guys. Make sure that you are taking notes. Make sure you do past papers galore. Just make sure you get all of them and just sit down and just do them and prepare really, really well, guys, because this is a very important step in your lives. And don't forget, we still have our Saturday show, so don't forget that. Thank you to Liberty also for such an amazing show. Bye-bye, guys. See you next time.